Hi again, so this is Muhammed Aziz again with a new session, and today we will talk about Go routines and Go channels. The Go routines are the threads basically which are managed by Go runtime, and these threads are amazingly awesome. These threads can make us capable to make our programs asynchronous, so they can execute with a concurrent approach. We can also call them unblocking statements. So the programs don't need to wait for some response from other section of the programs to actually continue with this execution. But in Go language, you can achieve that concurrency by using Go routines. Go routines are very lightweight. You can create tens of hundreds of thousands of Go routines, and it's not going to hurt you. But yes, do you have a constraint of your processing power? So if you want to make your program efficient, the Go routines are there, but you have to use it wisely. So let's see Go routines in action and how we can actually compare those synchronous and asynchronous approaches while programming in Go. Let's check this. Okay, so we have this small program where I have the main function, and there is two more functions which are show first name and show last name. And these two functions are basically running infinitely, and it's going to stop for 0.5 seconds each time when it's printing the first name and last name. And moreover, we are basically calling this function in our main function. So what is this doing? Let me run those, and you will see that it's going to print my first name, last name, and going on and on unless I stop this program, because this program is is synchronous program. So it is not stopping on this statement. This statement is not completing, so it is not reaching to that part of the program. So this is synchronous. So what we can do, let's make it asynchronous and see how it will go through. So to make it asynchronous, first let me stop this one, and I will just make this asynchronous by using Go routines. And for that purpose, what I will do, I will add Go to this function. Means this will create a Go routine for that function, and it will be working on the method at the background, and it won't stop this to proceed the program to reach to that point. While this Go routine is working at the back end, this will also start working in a very efficient manner. So now if I just going to run this again, so you will see what will happen. So you see this first name is going on, and last name is also there. So that means both are working with some stuff. So both you can see, because this is working executing asynchronously, and this is executing synchronously. So you can see all those things. So let me stop this one. And just one thing, I just instead first name I will say last name to make it look different. Now you see the both program running concurrently. I mean, both functions are being executing concurrently, one with the help of coroutines, other is without coroutine. So what we can do, we can also make this coroutine, and you will see a little bit different behavior here. Let's run again. So what happened? Nothing is printing. So what happened? The Go routine is basically executed this program, this function, and then starting with this one, and once it just done with these two Go routines, is just exited from the program. So that's why you can't see anything in the console where I just run this one, because both are running, both has completed their routines, and they just exited from the main function. So this is what it is all about. Before, you can see the printout statements, because this was running synchronously and the program was waiting here because it's a blocking statement in synchronous, and that was working as asynchronous. So that's why you can see some printouts here. So what you can do here, I can just add time of like time sleep. I can say just wait for 2 seconds and see how much it can go in the 2 seconds. So you see in 2 seconds we have this only these two lines which we can see. There is another way of doing it. We used to do in C++, but they are also same here. So you can use that scan line, which is basically waiting for input from the user, and once the user gives any input, it will start basically executing from the program, because the both routines go routines will be executed, and then when it reach to this point, it will wait for the input from the user using keyboard, and then from there, when any key press has been received by this function, the program will execute, because we don't have anything behind under this line. So let's run again. So you will see it keeps running, you can see, and the time when I will press any key, it will stop because of this format scan line. Though it's not a good behavior, we have to see our routines, that their execution, their working, I mean their response in our console. So let me clear the screen for now. So for that purpose, we have another statement in Go, which is called wait group. So in the wait group, we create a wait group and ask the program to wait unless our Go routine finished and we got some output. So let's check with the wait group. Let's create a wait group variable, and it will be sync dot the other variable was dot wait group, and you will see that it automatically add the related package in the import. So this wait group has been added, and then what you need to do, the how many routines are basically working. So I will say wait group dot add. This is what we are taking care about. That there is right now one routine which will be working. So I will do that. Now this wait group will basically work with one go routine, and checks if there's any messages, any responses, any response which is basically coming, because we have one in the wait group. So it's waiting for one go routine basically. Okay, so what I will do, uh, I will add this wait group here as a pointer, but I think this is not the responsibility of this function to take care about this wait group. So I will create a anonymous function here, and that anonymous function is going to take care about that one, and that is basically will be the go routine for us. And here, and I will just use it right away, and in here I will call my this function, which is show first name. And once this is done, what I will do, I will say that our wait group is done, and it will be decrement this one value to back to 0. So to not make it this function anymore the infinite, let's make it to go like 5. And because this wait group variable is inline, so it is available here as well, and I can say wait group dot wait. Okay, the thing is, I have created a wait group. At the wait group, I have added one routine and asked it to run it with the synonym function, and so anonymous function. And the anonymous function, once this will be done, we will decrement this go routine from here by using this done, that this go routine has been completed successfully. And then the program will come to the wait, and when the wait will see that there is no go routine which needs to run, it will terminate the program. So this is all about a bit about the wait group, but let's run this and see how it will behave. There you go. So it started from 1 and go up to 4. Just make it like equals to make it completely 5 for now. So it will go like 2, 3, 4, 5, and you can see all the messages which is coming from this function, and that is running as asynchronously in our anonymous function. Okay, so to make it more better, let's use channels. Those channels are used to actually communicate in between the Go routines, so they can also send the message, they can receive the message, and they are of blocking nature. I mean, they work like synchronously. So the channel is basically block a statement until it's ready to receive, and the channel is also blocking the statement, which is basically unless it is ready to send something. So in both receiving and sending, they have the blocking nature. So instead of sending like this one, while we are using for the wait group, let's remove these things, and we don't want to go over like this. And here I will pass an extra argument which will be of nature channel. So C channel, it also contains the type, so in our case it is string. So what I will do, I will basically send back this channels string which we have, and this will be an arrow, and in our case this is text, and it is going back to the channel that is we are sending from this function to our go routine using the channels. And let's make the same thing here in our second function. And yes, so I will also make this to go with like, all right, so now come here. Here we have to pass an extra channel variable, which will be, I will create a new variable here by using the make function, and I will give the type which is channel and it's the value string, and I will pass here C. Now this C is basically a channel type of a variable which is receiving this text from this coroutine. So I will run this coroutine and I will say message equals C, and here fmt dot print line, and the same message I can give. Let's go with message for now. Okay, and let's run this. That's interesting. The message is coming very weirdly because I didn't add the properly message here. There you go. So I have to put that this channel is sending back the message in the message variable. There you go. I can say infinite for, and here I can use this one. So till then you're receiving the message, just keep printing on here. And now run this. Let me clear the screen first. I'm going to run this. You see it's running, and then we have an error of deadlock. Why the deadlock is there? Because this is indefinite loop, infinite loop. It keeps waiting that the messages are coming, but the message like 1 2 3 4 5 coming, and there was no message, so it just throw a fatal error of deadlock. So the reason behind it, we are opening the channel, but we also need to close the channel once we don't need this one. So for that one, what you need to do, you just go here and close your channel. And same thing I will do here as well. Close my channel, because after this program execution, we won't be needing any channel in here. So now run this. Muhammed is printing and it's done. So in that case, you see the channel has been closed, and it's successfully completed the execution. Still we have an exit status here. Why it's like that? Okay, so I think I know what the issue. We are closing the channel here, but we are not telling this system that the channel is open or not. So for that one, what we can do, we can just pass another variable called open here, and here we can see if not. So if open, then break. If the channel is not open, then you have to break from this statement. So now let's run this. There you go. Now that error has also been counted. So the thing is very simple, straightforward. We have created the channels, and the channels are communicating between the go routines, and we also closing the channels and checking with an extra parameter if the channel is closed or not, and then we can perform the operations. So the another practice to doing this, that you can check here that for message, sorry, and message, and it will be like range of C. So you keep using this one, and we then don't need this and this as well. So let's run this. So that's the most common practice which is being used to check the messages and check the channel is open or not. All right, so this is the channel, and the very important concept of blocking and non-blocking. Let's test that one. For example, if I'm going to start one and creating two channels, C1 and then C2. Now there are two channels, which is C1 and C2. And what I'm going to do, I'm just going to do that hello, right? So I'm going to use it, and then in C2, I'm going to use hello world, and let's run this, see what happens. Okay, so the problem is now you can see all Goroutines are asleep and we got the error of deadlock. So we are trying to send a hello message to C1. I mean, we are trying to receive this message, but our receiver is not ready. So you see the blocking the statements, like we are trying to send hello and word to these two channels, and then we just want to receive these two messages in our message string, which is like oh boy, C1, right? And same here, C2, and I can see the message one declare not used, and then let's do it different. Let's do this message here, and if I'm going to run this one, you will see again is all Goroutines are asleep and it's a deadlock issue. The thing is that we are sending message and trying to receive while the sender is not ready to receive, because we should have a Goroutine to actually work with these things. The issue is here because we are using the unbuffered channel. So we can also create a buffered channel, which will going to work this one. To make a buffered channel, I can say like make it a size of 2 here and here as well. So now we have given a capacity of the channel to store some values, and now run this thing. So you see hello world has been printed because we have a buffer of 2 values in here. Now here again we need to print the message C1, the message is 1. So now hello world is there. Now let's send another message to see that how it will behave if we are sending more messages. Even though the buffer size 2, it should be full now at this point. And if I run this, so you see we have a all routines or sleep deadlock issue again, because the size of the channel is 2. We can say we can have a capacity of 2 messages, but we are sending 3. So if I go to make it 3, it will be solved issue. There you go. So in this way we can define the buffered and unbuffered channels, and we can use those as per these needs. So I hope with these very simple examples you understand that what are the channels are and how those are working inside routines, and how we can make the best use of those by performing asynchronous programming. And I hope you like this one, and then I will see you in our next session. Take care. Bye bye.